Good afternoon, everyone. Next, we are going to see about HCI in software process, human-computer interaction in the software process. How HCI is involved in software process. A software engineer under the design process for interactive systems, usability engineer, iterative design and prototyping, design rationale. So these are the topics we are going to see in this topic, right? First, the software life cycle. Software engineering is the discipline for understanding the software design process or life cycle. Designing for usability occurs at all stages of life cycle, not as a single isolated activity. A software tool is a programmatic software used to create, maintain, or otherwise support other programs and applications. Some of the commonly used software tools in HCI are as follows. Specification method, grammars, transition diagrams, state charts, interface building tools, interface mock-up tools, software engineering tools, evaluation tools. So these are all the some of software tools commonly used in HCI. The first one is specification method. The method used to specify the GUI, graphical user interface. Even though these are lengthy and ambiguous methods, they are easy to understand. Next, grammars. Written instructions are expressions that a program would understand. They provide confirmation for completeness and correctness. This is called the grammars. Transition diagrams, set of nodes and links. Set of nodes and links that can be displayed in text, link frequency, state diagram, etc. They are difficult in evaluation visibility, modularity, and synchronization. So this is transition diagram. Next, state charts. Chart method developed for simulation, user activities, and external actions. They provide a link specification with interface building tools. Next, interface building tools. Design methods that help in designing command language, data entry structure, and widgets. Next, interface mockup tools. Tools to develop a quick sketch of GUI, for example, Microsoft Visio, Visual Studio, .NET, etc. Next, software engineering tools. Extensive programming tool to provide user interface management system. Next, evaluation tools. Tools to evaluate the correctness and the completeness of programs. So these are all the some of the software engineering tools in HCI. So in here the software engineering and HCI, how the software engineering is involved in HCI or how the HCI is involved with software engineering. Software engineering is the study of designing, development, and the preservation of software. It comes in contact with the HCI to make the man and machine interaction more vibrant and interactive. Let us see the following model in software engineering for interactive designing. The next slide is waterfall model. So this is the interactive designing of software engineering. So in waterfall model, we are having some 6 phases. The first one is a requirement specification, architectural design, detailed design, coding and unit testing, interaction and testing, operations and maintenance. These are the 6 stages are there in waterfall model for developing a software. These are all the software process. So here we are seeing about activities in life cycle. A requirement specification. This is the first phase of software process, software interaction process. The requirement specification. Designer and customer try compute what the system is expected to provide can be expressed in natural language, more precise language, such as a task analysis would provide. So this is requirement specification. Next, architectural design. High level description of how the system will provide the services required factor system into major components of the system and how they are interrelated needs to specify both functional and non-functional requirements. So this is architectural design. Next, detailed design. A refinement of architectural components and interrelational to identify modules to be implemented separately. The refinement is governed by the non-functional requirements. The next slide is verification and validation. Before that, the unidirectional movement of the waterfall model, about the waterfall model. So the unidirectional movement of the waterfall model of software engineering shows that every phase depends on the preceding phase and not vice versa. However, this model is not suitable for interactive system design. The interactive system design shows that every phase depends on each other to serve the purpose of designing and producing creation. It is a continuous process as there is so much to know the users keep changing all time. An interactive system designer should recognize this diversity. Prototyping. Next one is prototyping. Prototyping is another type of software engineering model and can have a complete range of functionality of the project system. Let's say prototyping is a tried and partial design that helps users in testing design idea without executing a complete system. Example of a prototype can be sketches. Sketches of interactive design can later be produced into graphical interfaces. The medium fidelity prototype involves some, but not all procedures of the system. For example, first screen of a GUI. Finally, a high fidelity prototype simulates all the functionalities of the system in the design. This prototype requires time, money, and workforce. Next, user-centered design. The process of collecting feedback from users to improve the design is known as user-centered design or UCD. The drawbacks of UCD: passive user involvement, users' perception about the new interface may be inappropriate. Designers may ask incorrect questions to users. So these are all the HCI with software engineering. Next, verification and validation. The verification, designing the product right, and the validation is designing the right product. So there is a difference between verification and validation. Verification means whether we are designing the product right, what the expected, what we analyzed in the previous page. That analysis can design as a product right or not. Next, validation, whether we are validating the right product or not. So the customers gave an idea. So based on that idea, we have analysis and gathering all the requirements before starting the one process, software process. So whether we are get the right product or not, this is called validation. Next, the formality gap. Validation will always rely to some extent on subjective means of proof, management and constructual issues, design in commercial and legal context. The life cycle for interactive system. Actually, the stages in the following diagram are represented until the solution is reached. So, see, the first one is requirement specification, architecture design, design detail, detailed design, coding and unit testing, interaction and testing, operation and maintenance. So these are all the phases here, and each and every phase can be interact with the each and every phase. So this is the interactive system. So before that, we are seeing the waterfall model. That waterfall model, we are having only one phase connectivity. So requirement to architecture, architecture to detail, detail to coding, like that. Here, every process or every stage can interact with the previous stages. So this is interactive system. So also we can say GUI design and aesthetics. Graphical user interface is the interface from where a user can operate programs, applications, or devices in a computer system. This is where the icon, menu, widgets, label exist for the user access. It is significant that everything in the GUI is arranged in a way that is recognized and pleased to the eye, which shows the aesthetic sense of the GUI designer. GUI aesthetics provides a character and identity to any product. Next, usability engineering. The ultimate test of usability based on measurement of the user experience. So actually the engineering is based on the user experience only. We can give a feedback. Usability engineering demands that specific usability measurement be made explicit as requirements. Usability specification. So there are four specifications are there in usability. Usability attribute or principle, measuring concept, measuring method, now level or worst case, planned level, best case. So these are all the specification of usability. And the problems of usability is usability specification requires a level of detail that may not be possible yearly in design specification. Your usability specification does not necessarily satisfy usability. Next, part of a usability specification for PCR. So this is we are having an attribute background recoverability. So here, measuring concepts, we are having some attributes here: measuring concept, measuring method, now level, worst case, planned level, and best case. So in usability, in measuring concepts, uh, undo an erroneous programming sequence, measuring method, number of explicit user action to undo current program. Now level, no current product allows such an undo. Worst case, as many actions as it takes to program in mistake. Planned level, a maximum of two explicit user actions. Best case, one explicit cancel action. So this is the attribute of our background recoverability. ISO usability standard 9241 adopts traditional usability categories. Here we are having three categories: effectiveness, efficiency, and satisfaction. So in effectiveness, can you achieve what you want to? In efficiency, can you do it without wasting effort? In satisfaction, do you enjoy the process? So these are all the three categories of usability. We are having some metrics from ISO 9241, usability objective, effectiveness measure, and efficiency measures, satisfaction measures. So based on this only, we are providing some ISO things. Next, iterative design and prototyping. So iterative design overcomes inherent problem of incomplete requirements. Next, prototypes uh, simulate or animate some features of intended system. Different type of prototypes throw away incremental evaluationary and management issues, time, planning, non-functional features, and contracts. Next, techniques for prototyping. Storyboards, limited functionality simulation, warning about iterative design. These are all coming under techniques for prototyping. In storyboards, need not be computer based, can be animated. In a limited functionality simulation, some part of system functionality provided by designers tools like hypercard are common for these wizard of Oz techniques. Warning about iterative design. Design in yearly bad decision stay bad. Diagnose real usability problem in prototypes and not just the symptoms. So next, design rational. Design rationale is the information that explains what a computer system is the way it is. Next, benefits of design rationale is benefit of communication throughout life cycle, reuse of design knowledge across products, enforce design discipline, presents argument for design trade-off, organized potentially large design space, capturing contextual information. So these are all the benefits of design design. So guys, we are going to stop here. Next, we are on remaining topics and remaining things we will say in next class. Thank you.